See, these are the formulas. Okay, so XL is only J omega L. Okay, and XC is how much? 1 over J omega C. So you can write down this thing or this thing, both are same, but in actual the basic is XL only. Okay, this formula is equal to J omega L. That's why they have write it directly that inductor impedance is J omega L. And why they write it 90-degree, that's what I'm saying, that as you know, in inductor, in a case of inductor, the phase angle is 90-degree, right? And in case of capacitor, it is negative 90-degree, right? Why? Because I told you that in this case, suppose voltage is here and current is here, so they have taken with the different reference. So they said voltage leads the current by an angle of 90-degree, right? If you have taken current over here and voltage like this, then tell me how much is the angle? 90-degree now. It is leading, it is positive or negative? See, it is case of, I told you, in case of inductor, current lags voltage by 90-degree, right? I told you this statement. So from this statement, can we say that voltage leads current by 90-degree? So if I'll draw it with reference of voltage, then current lags, right? Then current is in downward, then it would be 90-degree. If I'll draw with terms of voltage, then in that case, sorry, if I'll draw in terms of current, then in that case voltage leads 90-degree. So voltage is here. So both the phasor diagram is same, right or not? In the both the cases, voltage is leading. Here also voltage is leading, and here also voltage is leading. Correct or not? Or if we'll see by phi is equal to tan inverse XL by R, then also here R is 0, right? So R is 0 means tan inverse infinity, and tan inverse infinity is how much? 90-degree. So that's why it is 90-degree. Got it? Now you got it how they are getting the angle as 90-degree. Similarly is the case of capacitor. Okay. Now you tell me about the case of capacitor, how it would be minus 90-degree. For inductor it is leading, and for capacitor voltage is lagging, right? If voltage is lagging, then it would be angle is minus 90-degree, right? Clear? Okay. Now anything want another doubt you want to ask? Okay. Now after this, what you need to do, the voltage division rule. Did you remember the voltage division rule which you have studied in DC circuit? What was the rule? Tell me. Now we'll study this thing in the AC circuit. The same rule is there. Like suppose this one is Z1, this one is Z2, and this one is Z3, right? So the total voltage is V. Here the voltage is V1, positive, negative. Voltage here is V2. Here the voltage is V3. Current here I is flowing. So what would be the voltage V1 value formula according to voltage division rule formula? Tell me. V1 is how? No, you have to use voltage division rule. What is the formula? Z1 plus Z2 plus Z3. Correct? Now similarly tell me for V2. And similarly you can get it for V3, right? Now with the voltage division rule, what is the next formula? That is current division rule. Yeah, and if suppose they are in parallel, okay. Now I am taking the three impedance. First we'll take the two impedance Z1, Z2. Here the total voltage is V and the current flowing here is I. This one is I1, this one is I2. Now tell me I1 is how much? Current division rule. Yes. Similarly I2, it is I total current, right? So I multiplied by Z1 over Z1 plus Z2. Got it? Now suppose what will happen if we'll have, instead of two impedance, we'll have three impedance. Then in that case, tell me, I'm saying instead of two impedance, if we'll have three impedance, then what will happen? Then it's better to convert three impedance into two. Okay, then use this formula. We'll have one direct formula also for three, but that would be too confusing for you, so I won't suggest to remember that formula. If there would be three impedance, convert it into two. Got it? Now the next question from your slide only. Draw the diagram. In this they have given L is equal to 0.1 Henry, R is equal to 100 ohm, and C is equal to 10 microfarad, and plus minus Vc, and this one is Vs. Vs of t is equal to 10 sine 1000 t. Okay, so now in this case you need to calculate what? You need to calculate Vc. Now tell me, how can you get Vc? These are not in series, they are in parallel, right? So you can do one thing. Can you convert these two impedance into a single impedance? Then the circuit would be converted into a series. Yes or no? Hmm? Yeah. So tell me, how can we convert it into the parallel? It is ZRC is R parallel ZC, and ZC is how much? 1 over A omega C. Then minus J over omega C if we want to shift J to the above, right? Then after that, do you know the value for C? Okay, tell me the value for omega. It's not W, it's omega. Okay, omega is how much? 1000, right? So that would be how much? Minus J over 1000 into 10 minus 6. How much will get it? minus J 100. Okay, right? So now we need to calculate this one also. ZL, right? ZL is how much? J into omega L. Tell me the value for ZL as well. Solve it and then tell me. ZL is how much? How much? J 100 now? Okay. Now convert this voltage into a polar form. Tell me what would be the voltage in the polar form? Hmm? Voltage in the polar form. By 100 by 100 angle. Right. Polar one is with the angle. Y angle is 0. What is the standard equation I told you? Okay, remember the standard equation is what? Standard equation is the form of sine or in the form of cos? In the form of cos. So what they have given? They have given you the sine. You need to convert it into the cos form, right? So cos form is how much? Yeah, so it 10 cos 1000 t minus 90. Correct? Now can you tell me, convert it into the polar form now? 10 angle minus 90, right? So voltage is given. Now if I convert this whole diagram into the Excel or in the standard form which we require, right? So ideally it should be like 10 angle minus 90 J 100 ohm, resistance 100 ohm, this one is minus J 100 ohm. Now this is R and C combined, it that would be ZRC, that would be ZR parallel ZC, ZR multiplied by ZC. Yeah, you can convert it into polar form. How can you convert? Pole 0 comma minus J 100. Okay. Hmm? How will you change? By hand? By hand you can do it directly. If 0 resistor is not there, if there is not resistor, that means only capacitor. Only capacitor means, that is pure 90 degree, right? 100 angle minus 20 degree. Just try to convert it. It would be same or not, just check it. Now solve it and then tell me the value for ZRC. Do it by this method. Okay, ZR multiplied by ZR plus, instead of doing 1 by minus 300. The complete value of ZRC. Hmm. For the whole you are telling me? No, the combined it is 70.7, angle is minus 45. If you convert it into rectangular form, then it would be 50 minus J50. You are getting the same or different? Okay. Now see, I'll redraw the diagram. Remain, vector will remain, and after combining ZRC, right? So that J100, this is 10 angle 9 minus 90 degree. This one you got it as 50 J50, right? Or you can find 1 angle minus 5. Now calculate by using voltage division rule. What is the voltage division rule in this case? Hmm. 70.71 minus 45 divided by 50 minus J50 plus J100. Okay, here I need to add now, that's why I have taken in rectangular form. Solve it and then tell me the value. Be 70.71 angle minus 45 divided by 50 plus J50, right? Convert this 50 plus J50 into the polar form. What you are getting? For polar you need to press again. Okay, angle is, there is some mistake. Okay, this is also there now. So it would be how much? This would be cancelled 1 and angle minus 45 minus 45, right? It would be minus 90, right? So now 10 angle minus 90 multiplied by 1 angle minus 90. How much is the answer? Minus 180. This is your final value for VC, that is 10 angle 180. Clear? Now tell me this VC in the equation form. What is the value for VC in the equation form? No, in the form of cos. Whenever I say equation, that means you need to tell me in cos form, the standard form. Hmm. Hmm. W was given, it was same W, omega 1000. Whenever they'll ask you the voltage, you don't need to leave this in this form, you need to convert it into this form. This is automatically understood. Okay, they don't mention it that you have to do it this form. If they have given voltage in this form and they are asking the voltage, you need to tell the voltage in this form. Okay, now after this tell me current. How much is the current flow? Total current is the formula for the current in the same circuit which they have given. I total current you need to calculate. They are asking the total current. How, tell me how to get the total current. No, you don't need to. You already convert into current now. In this case, you convert this circuit. Now this I and this I would be same or different? Hmm? This is already you convert to the equivalent. So now I'm asking this I and this I is same or different? Here it is also the total current. So instead of using this form, we can use this form, right? Tell me how can we get current? Hmm, hello. Yeah. Now we need to calculate current from this form. Tell me how can we get it? Hmm. Okay. Which formula you are using? You need to calculate current. So why you are using the voltage division rule formula? First tell me. Okay. Now why you are using current division rule? It's applicable only in parallel circuit. It is parallel. Parallel circuit is there? No. So just simple imagine that's a simple circuit with two resistance and one voltage. Then tell me how can you get the current? Yes. I is equal to V over Z, right? Voltage is how much? Okay, tell me. Voltage is how much? And impedance, total impedance is how much? Hmm? Total impedance is how much? Tell me. And so it would be how much? 50 plus J50, right? 50 plus J50, and voltage is 10 angle minus, right? Solve it and then tell me. No, no, no. It is 10 angle minus. It is not this you are getting as exactly. I is 0.14, angle would be minus 130. Are you getting the same? One watt means 15 plus J50. 50. Okay, maybe that. Now in this case, calculate IC. This one. Now tell me how can you get IC? Hmm. We can use the current division to it. Tell me the value for IC. How can you get IC? Equivalent of the inductor resistance, right? That you already calculated, right? Now here you need to calculate IC by using current division formula. Okay. Now tell me how will you get IC? Hmm? Hmm. I is equal to I divided by 100 divided by 100 minus 300. Yes or no? In current division rule, we don't use. I told you what is the current division rule. Total current multiplied by the opposite resistance divided by the sum of resistors are connected in parallel. Got it? Now tell me IR. How can we get IR? You are not understanding, right? Because if you are understanding, you are fast. Tell me where you are having doubt. Solve it. Do you already calculated the for I? No. Yeah. One for 1 point angle is multiplied by the current also calculated 0.4141 angle, right? Solve it. Yeah, it is for one. Tell me the final answer of IC. That you are telling me for IC, right? 0.1 angle minus 120, 180. This is the final answer. IC is 0.1 angle minus 180. Minus 1. Calculate IR. Okay. It is IC equal to current, right? So total current we got it as angle minus 5 multiplied by the branch. Opposite branch is 100 divided by sum, that is 100, right? Okay, now calculate IR. Higher value you are telling me. Higher value is zero point 0.1 angle minus 90. Sorry, minus 181. Wait. Yeah, 0.1 angle minus 90. Check it also. Like I see I R you are getting 1. I would be higher plus you are doing calculation that you have done. I'll tell you what answer. IR is equal to the total current, 0.141 angle minus 1.5 multiplied by the opposite branch. Opposite branch is minus 100 divided by the sum 100 minus 3, right? For this one, convert it into polar form. We are saying 100 angle minus, and for this one, okay, it would be minus 90 plus 45. Angle would be minus 45. So minus 45 and minus will add it. Slides there. I, IR is correct, minus opposite. In your slide it is, I'll show you. You are correct because in resistor, obviously, angle of Z can't be 90. Done. They said IR, here IR is, they wrote it IC. Actually, they interchange it. Their mistake. Okay, understood now? Okay, now they are saying node voltage, the phasor. Okay, okay. done.